A wonderful day to all of you. For today's topic, we'll be tackling about identities and we'll be showing you examples to expand your knowledge about this topic. But before that, let's familiarize ourselves with the ratio identities, reciprocal identities, and the Pythagorean identities to make this process a lot easier. For our ratio identities, we have tangent theta is equal to sine theta over cosine theta, and cotangent theta is equal to cosine theta over sine theta. The reciprocal identities are sine theta is equal to 1 over cosecant theta, cosine theta is equal to 1 over secant theta, and tangent theta is equal to 1 over cotangent theta. And lastly, for our Pythagorean identities, we have cosine squared theta plus sine squared theta is equal to 1. 1 plus tangent squared theta is equal to secant squared theta, and cotangent squared theta plus 1 is equal to cosecant squared theta. Knowing all these identities, we can now proceed in verifying them. For our first example, our equation is tangent x plus cotangent x is equal to secant x times cosecant x. In this equation, we'll be proving the left side of the equation, which is tangent x plus cotangent x. First step is to find the ratio identity of tangent and the cotangent. According to the ratio identity, tangent is equal to sine over cosine, and cotangent is equal to cosine over sine. So the equation will be transformed to sine x over cosine x plus cosine x over sine x. The next process is to add them. Butterfly method will be used. Sine x times sine x is equal to sine squared x, and cosine x times cosine x is equal to cosine squared x. Then, we have to combine the denominator. Our equation will be sine squared x plus cosine squared x over cosine x times sine x. According to the Pythagorean identity, sine squared x plus cosine squared x is equal to 1. Therefore, our equation will be transformed to 1 over cosine x times sine x. So our equation now will be transformed to 1 over cosine x times sine x. The next step is to separate them. So our equation will now be 1 over cosine x and 1 over sine x. According to the reciprocal identity, 1 over cosine x is equal to secant x, and 1 over sine x is equal to cosecant x. Therefore, we proved that the left side is equal to the right side. For the second example, we have tangent theta over secant theta minus 1 is equal to secant theta plus 1 over tangent theta. We'll be proving the left side of the equation. We will find the corresponding term to make the equation possible. Our equation now will be tangent theta over secant theta minus 1 times secant theta plus 1 over secant theta plus 1. Then we have to multiply both equations. Our answer would be tangent theta times secant theta plus 1 over secant squared theta minus 1. Since secant squared theta minus 1 is equal to tangent squared theta, we can now change our denominator to tangent squared theta. Our equation now is tangent theta times secant theta plus 1 over tangent squared theta. With this, we can now use cancellation, and the answer would be secant theta plus 1 over tangent theta. Therefore, we prove that the left side is equal to the right side.
Now, for our third example, we'll be discussing an easy question. We'll be proving secant 4 theta minus tan 4 theta over secant squared theta plus tan squared theta is equal to 1. The side that we'll be proving is the left side. For the first step, second for theta minus tan for theta is to be factored out. Therefore, it will be second square theta minus tan square theta and second square theta plus tan square theta. The equation will now be second square theta minus tan square theta times second square theta plus tan square theta over second square theta plus tan square theta. The next step, cancellation will be used since in our equation, it is possible to use this. We'll cancel second square theta plus tan square theta from the dividend and second square theta plus tan square theta from the divisor. With that, we are left with second square theta minus tan square theta. Going back with our previous discussion, second square theta minus tan square theta is equal to 1, as the Pythagorean identity justifies. Therefore, second square theta minus tan square theta is equal to 1, which proves that the two equations are equal.
So in this equation, we need to prove that sine squared theta plus 2 cosine theta minus 1 over sine squared theta plus 3 cosine theta minus 3 is equal to 1 over 1 minus secant theta. So it is better to simplify the left side of this equation because it is the more complicated one. First, we need to convert the sine squared theta to 1 minus cosine squared theta, so we will have 1 minus cosine squared theta plus 2 cosine theta minus 1 over 1 minus cosine squared theta plus 3 cosine theta minus 3. After that, we will combine the constants, so 1 plus negative 1 is equal to 0 and 1 plus negative 3 is equal to negative 2. So now we have negative cosine squared theta plus 2 cosine theta over negative cosine squared theta plus 3 cosine theta minus 2. Then, we can multiply negative 1 and negative 1, which is also equal to 1, to make the leading terms of the numerator and denominator positive. So now we have cosine squared theta minus 2 cosine theta over cosine squared theta minus 3 cosine theta plus 2. After that, we can simplify the values by using the factoring technique. In the numerator, you can factor out cosine theta, and in the denominator, you can use the factoring technique for the general trinomials. So now we have cosine theta minus 2 over cosine theta minus 1 cosine theta minus 2. Cosine theta minus 2 over cosine theta minus 2 because it also equal to 1, and that gives us cosine theta over cosine theta minus 1. Next, we can multiply secant theta over secant theta, which is also equal to 1. So secant theta times cosine theta is equal to 1, and secant theta times cosine theta minus 1 is equal to 1 minus secant theta. That gives us 1 over 1 minus secant theta, which proves that the identity is correct.
In this equation, we need to prove that cosecant x plus cotangent x over tan x plus sin x is equal to cotangent x times cosecant x. First, we need to change cosecant x to 1 over sin x, cotangent x to cosine x over sin x, and tangent x to sin x over cosine x so that we can simplify the fraction easily. So now, we have 1 over sin x plus cosine x over sin x all over sin x over cosine x plus sin x. After that, we combine the terms of the numerator, then we will simplify the denominator using the butterfly method. And that will give us 1 plus cosine x over sin x over sin x plus sin x times cosine x over cosine x. Then we will factor out sin x from the numerator of our denominator, which give us 1 plus cosine x over sin x over sin x times 1 plus cosine x over cosine x. And now we can proceed to division. So first, we will get the reciprocal of the denominator and multiply it to the Numerator 1 plus cosine x over sine x times cosine x over sine x times 1 plus cosine x. Then we can cancel out 1 plus cosine x over 1 plus cosine x because it is also equal to 1. That gives us cosine x over sine squared x.
After that, we can factor out 1 over sine x, and that gives us 1 over sine x times cosine x over sine x, which is also equal to cotangent x times cosecant x, and thus prove that the equation is correct.
And now is the end of our tutorial about proving identities. Hopefully, you learned something from us and we explained and delivered our knowledge about this topic clearly. We hope that this will be a big help in expanding your knowledge about identities. Remember that practice is an essential when it comes to proving these identities. Thank you and may you all have a great day.